Swayam Prabha. Digital India. Educated India.
Hello everyone, we are going to start a new course. It's called Evaluation of Textiles, the Analytical Approaches. Actually, we have gone through different courses in textiles and also the Evaluation of Textile Material course. In various colleges, these courses are taught as textile testing, evaluation of textile material, testing of textile material, like this. Also, you will find in Swayam platform, NPTEL, there is a course which is evaluation of textile materials, which deals with the testing part, basically, how to test textile material, like from fiber, yarn, fabric, and their testing methods are discussed primarily. But this particular course is entirely different from all these courses. Here, main focus is not the testing. Testing will just touch upon the testing part, how to test the material. Testing methods we will not discuss in detail. But after getting the test done, when we get the test data, how to actually apply this data in practical application, like in industry, for our research. So that's why this course, we are calling it as the analytical approach of textile testing. Here, we will be dealing with different modules. So we will go one by one. So today in module 1, I am going to discuss the introduction about this course and what are we going to discuss throughout this course. And before we introduce directly to the subject, first let us understand the background. We must understand the background of the course. So the outline which has been formed here is, first we will discuss that why do we need to test textiles. Because every performance is actually needs money. So it should not be only for the sake of testing. So we must have clear understanding of the idea behind testing of textile material. So that we will discuss here. Then the need of standardization. Like if you see a pen drive has got certain dimension. So why do you need to actually standardization? So I will show you one pen drive. So can you give me one pen drive? Is there one pen drive? If you see, so this is the pen drive. The size of the pen drive, the dimension of the pen drive must be exactly same throughout the world, because if this pen drive is produced by maybe many companies actually. So this, suppose today I have started producing a pen drive, okay, this, or a say battery. Its dimension has to be exactly same. that standard dimension should be, I should follow the standard dimension. Otherwise the problem would be that I will not be able to sell. If I deviate from the standard size, so I will deviate, if I deviate, then this pen drive will not be fitting to any of the computer or laptop. So it will be useless. Although the performance wise it's very good. So good or the best performance or high capacity it's not helping me, because I have not followed the standard size. So this, if you see, there are many such situation, many examples you can form. So this battery, if the dimension changes by say a fraction of millimeter, so it will be useless. So that's why we need a standardization of the shape or size. Similarly, we need standardization in testing conditions. So if we don't follow this testing condition, that may be textile testing, maybe any other testing. If we don't follow the standard method, then the problem would be we will end up with different result. Although same material I am testing, but if I deviate in the testing condition, we will end up with different result. That we will discuss in detail. For example, in tensile testing, if we change the gauge length, the tensile result, strength result will change. So that's why we need standardization. We will discuss in detail. And standards for testing of textile material. Earlier it was the testing condition. Like you need a particular relative humidity during testing, need a particular temperature for testing. It's a very common example, like cotton. If you increase the humidity, it's after absorbing moisture, it will give you the higher result. For other fibers, normally it reduces. So we need proper testing humidity and even temperature. If we increase the temperature, the test result will vary. Similarly, testing standard methods for testing materials is important. Then we will discuss the definition, some definition related to testing of textile material. So that we will discuss today. And then we will discuss the overview of the entire course. So initially we will discuss a few general terms, then we will discuss what are we going to discuss during the entire course. Okay. So let us come the first aspect. Why do we test textile material? First is the checking the quality and suitability of raw material and selection of material for testing. Okay. And material production. Now let us get one example. Like one company would like to produce any material, like in this table. The company's target is the product is this table or this any this chair or anything. Now before it starts its production. So this platform is made of the wooden or plywood, okay, and that we know this is used to actually carry certain amount of load, and for that it needs some bending strength or some compression strength, some tensile strength. So different types of testing quality characteristics of the raw material is required. Suppose the material here is required to carry, say, 10 kg, maximum 10 kg required is there. So accordingly the company will test the raw material and also its dimension. For this it needs a certain height, certain length or width. So then the product will be, ultimately the production will go on. Similarly, for textile material, suppose one company wants to produce, I will just show you, certain yarn. This is the yarn companies. It's what main product is the spinning mill. It's a yarn it wants to produce. So to produce this yarn, it needs certain fiber. So it gets the fiber, and because product is the yarn, but to produce the certain yarn, certain strength, that elongation, uniformity, the company first need the raw material. This raw material here is the cotton fiber. So cotton fibers raw material characteristics you have to go. So only by testing the yarn strength that the company will not be able to judge the final product strength. So to produce a certain strength or certain characteristics of the yarn, the company needs to first know the what is my raw material characteristics. So this raw material testing is first required. Then the next requirement is the intermediate material like card sliver or draw frame sliver material requirement or roving. So after this the company will try to test the sliver characteristics, the uniformity of sliver or fiber orientation of sliver or even nape content. All these characteristics will test. So next is that the monitoring of the process production, which is known as process control. So monitoring of the production of raw material, it is tested first, which is fiber for a spinning mill, or for this type of platform or table product producer, the raw material is the wooden platform. So they will test the raw material. Next is the monitoring of the production process. So how will you monitor? Like in blow room, in textile industry, blow room, so it's a process, fast process. So how will you monitor the production, blow room production process? So its performance, how is it performing? So blow room's main function is that the opening and cleaning. So we'll first try to get the cleaning efficiency of the blow room, or carding, the cleaning efficiency of the carding. Then blow room generates the nape. If the setting is not proper, the blow room generates the nape, then nape count we can do, and also in carding, blow room, the fiber breakages takes place. So we test the fiber breakage. So all these things are done to ensure the better quality. Suppose in blow room or carding, fiber breakage is taking place, enormous. Blow room high fiber breakage takes place. So that will indirectly or directly impact the quality of the material. Its evenness or strength will deteriorate. So this is blow room is one of the examples. Like then carding, suppose it's there is some improper action is there, so that you have to immediately go back to the machine. If its cleaning is not proper, or its hook formation is enormous, or breakage is there, then you have to take care of the setting and all this. Similarly, in draw frame, it is observed that suddenly the sliver uniformity is not, it's increasing. Evenness is actually deteriorating. So that means there may be some problem in setting, or maybe your the higher floating fibers. So we can control all this setting or speed we can control. So all these things are actually part of the monitoring of the production process. So this we are doing through testing, because we can monitor the process of blow room, performance of blow room, only by measuring the fiber length before blow room and after blow room. If there is a change, then we will come to know that okay, it's a really breakage is there. Okay, whether this impact is real, breakage will be there, but whether there is a significant impact or not, that for that we have to do statistical analysis. That we will do. Okay, here we are not only confining ourselves by testing. We will actually try to do the statistical analysis, analytical approach we will give, so that we are very sure that the effect is significant. If the effect is not significant, we don't have to actually disturb the production process. So that's why I told this course is entirely different from other courses where we only try to know how to test the fiber length or how to test the trash content and all this. Okay. So this is the process control, and then process development. So that's the basically through testing. How do we do process development? Let us again get the example of the blow room. In blow room, we found that the fiber breakage is taking place or nape generation is taking place. So in that case, what we do? We actually go back to the machine. Then we see that okay, for this particular fiber, the fiber characteristics we know, for this particular fiber, the setting which has been made, it's not actually optimum. So we will change the setting. So we will readjust the speed of the machine, or sometime we may change the component. So this actually, similarly, they will do it in all the stages. Okay, so that is actually called the process development. Or else, suppose we have this particularly yarn is today we are producing, but tomorrow our requirement, actually the customer's requirement is different. They need better quality, better strength. For that, what we have to do? We have to get the different raw material, different machine setting. So different environmental condition, everything will be there. Or maybe they require different, this is 100% polyester, tomorrow they need 50-50 polyester cotton. For that, you have to change the total entire process line. So that's how it's called process development. But to have process development, to do process development, you need testing. So testing is required in all these stages. Next is the assessment of final product. So we have done process development, we have monitored the production, we have done process control, we have done statistical quality control, everything we have done. Finally we have got this product. Now this product, how will you do? How are we going to be sure that this product is suitable for the customer? For that, the reference sample which we have got, or reference test or data we have got, we will test this product, in this case which is yarn. We will test for the, say, strength, uniformity, all these parameters, and if it is matching with our source or the target, then we will say the final product is suitable for use. Okay, so how will a yarn perform in the weaving? Suppose we are trying to use our own yarn for weaving. So weaving has got certain requirement. So we know this much strength should be there, this or everything should be there, or they need certain yarn linear density. So for that, if we can provide all these parameters, then this product will be accepted. Okay. Next is that investigation of the faulty material and identification of source of faults. So that's another actual objective of testing. Like this is the raw material which we are getting from outside. We cannot be sure, and we should not be actually blindly believe that this material is actually as per our standard. So this faulty material, so this may be faulty. So for that we are testing. Like this is giving thick and thin places. This sliver is giving thick, thin places. This is a faulty sliver. But how do you test the faulty sliver? Just let us see. The yarn, so in the ring frame, we are getting yarn which is having thick, thin places. These thick, thin places are mainly due to if it is, say, random, so it's a periodic. If it is periodic, this will be due to some roller defect or some pinion defect. So that we will analyze based on the wavelength. So that's basically investigation of faulty made. This is a faulty made product. We are analyzing this by one instrument, maybe witness tester here, and then we identify that it's a periodic fault. That we will discuss in detail, which is actually when we will discuss the spectrogram analysis. And after analyzing, so this is a draw frame. Draw frame. draw frame, speed frame, and say a ring frame. And after testing the yarn, we have got certain wavelength, okay, X. So this wavelength will match with all this detailed we will discuss subsequently, will match with whether this is actually source is ring frame or speed frame or draw frame. That we will do through the analytical approach. We will identify the root cause, and if we can identify the root cause, we will be able to actually eliminate this fault. Okay, so that we will discuss. This is actually one of the tests. So this unevenness or this location of the fault we can only do if we test the material. Okay. Product development. This is one particular blend, or say 100% cotton. Now we want to develop certain new yarn. Like this yarn, we want certain fancy effect, or maybe with some twisting effect. This product, to develop this product, we need different types of raw material, different types of process parameter, different types of machine parameter, and that we can ultimately achieve through testing. So without testing we cannot do product development. Tomorrow we want to develop certain products from bleached fabric, gray fabric, bleached fabric, dyed fabric. So you are trying to develop a certain particular dyed fabric. For that you need to test the concentration of the material or shade. You have to match the shade. So everything, every aspect we have to test the material. And specification testing, that we have actually already discussed. So customer has given certain specification, and to match the specification we have to test. So for this yarn they have given certain strength, elongation, evenness. So just to get that particular specified value, match the specified value, that we have to test. Now the thing is that whether, suppose they have given a strength of, they need a strength of 10 value, 10 centinewton per tex for a particular yarn, and what you are doing, you are giving strength. The higher the strength, better is the quality. Now if they are asking for 10 strength and I am giving 20 strength and I am very satisfied, it is actually giving my purpose. It will not fail. They need certain unevenness, U percentage, 10 U percent. I am giving say 5 U percent. I am very happy that I am giving very good quality. My customer will be happy. Now is it the right approach? Definitely not. It's not the right approach. When the buyer is asking for 10 centinewton per tex, that means he is paying the price for 10 centinewton per tex, not the 20 centinewton per tex. 20 centinewton per tex, if you want to produce, you have to use better raw material, better fiber. So that is actually you are actually investing more money to produce the same quality, same quantity of it. So that's not the so the quality which you are talking, quality of 20 that with a 20 centinewton tex is better than 10 centinewton tex, but our target is to produce 10 centinewton per tex. Now tomorrow for specification testing, if you find in your sampling, when you are finding the test it is giving 20 centinewton per tex, suddenly you should be worried. I should not give. So you are reducing the quality of the raw material. so that you can balance the profit margin. Okay, so that's because the testing here also, specification matching means it's not the achieving the target, also how much you are exceeding the target. If you are exceeding the target, it's not also good approach. Okay, now I have already explained the need for standard testing. So in standardization, we have discussed the in general why do you need a standard size, that we have discussed only standard shape or size. Okay, that's very important. So one must follow the standard. Similarly, one must follow the standard procedure for testing, not only for textile, for any other material. Like the need is there, the lack of reproducibility in the test result may occur due to variation in the material. So the raw material which we are getting, we cannot get, suppose for cotton particularly, or maybe wool or natural product, we cannot get the same material. It's for sure. We cannot, if it changes with the climate or many aspects. But our final product has to be uniform. Same quality you have to give. So the raw material, the variation has to be minimized. So how will you minimize the test rate? Suppose this, in this material, okay, so we have different mixture. Okay, at different portion, if you see, the material may be different. Okay, because this is collected from different balls, so their maturity will be different. Now, how to get the standard value out of this? So the variation in the material is minimized by the proper sampling. So if we form a proper sampling technique, so we will discuss how to sample the fiber, yarn and fabric. So if you follow the proper sampling technique, then we can achieve the standard value, standard result, uniform result. So here the from different bale, so there may be 100 bales. If we pluck the sample from different bale, so we will land up with different result. But if we follow the standard proper sampling technique, we will get approximately similar result. Okay. Use of suitable statistical method to analyze the test result. So we'll discuss how to use different statistical method to analyze the test method. Okay. Then variation due to test method. So test method variation, it will give us the different result. Although material is same, for same material we may actually get the different results due to the test method. Like due to operator, lack of care of monitoring the specimen. This is one example. Like you can see here, this is a top jaw and bottom jaw, and we are testing the yarn sample. Here, if the operator is not careful in actually putting the material in the jaw or fixing the material in the jaw properly, if the the jaw is loose, what will happen? The material will start slipping. You will get altogether different result. Like if you see the stress strain curve, stress strain curve here, for the operator where he is not putting the material in properly, there is a not very tightly or not optimum tightness, it's loose. So what will happen? The data will be like, first let us see the operator has done the proper, he has followed the proper method of clamping. Proper method of clamping, and this he is getting, this is the correct curve, correct stress strain curve of say cotton yarn. Now when he is not following the proper, he is not actually clamping it properly, it's not proper tightness, the curve will be like this. Okay, that means there is a slippage, jaw slippage is there. So, and if he is putting higher pressure, he is clamping at very high pressure, what will happen? There will be a damage here, damage. So it will be like, so this is a normal, it's a jaw slippage, and this is a damage. So same fiber, only due to operator, same yarn or fiber, maybe anything, only due to operator's problem, we are getting different results. So that's how, what has to be done here? Operator has to be trained with certain standard value, standard procedure. Operator has to be told that okay, you should follow this particular process, you have to tighten this one. So there must be some document which will guide the operator to follow the exact process. Okay, so that's why we need standardization of the testing method. Next is the specimen size. So one operator is actually, this is one. Next is that now this is yarn, and another this is the yarn side. This is A, B, L1 is the gauge length, here L2 is the gauge length, where L2 is more than L1. So when he is the person, when he is using the L2 gauge length, then he is going to get the lower strength for same material. This we will discuss, it's called the weak link effect. Okay, so this, due to all this specimen size, then atmospheric condition, the person here, the standard atmospheric condition is that 65% relative humidity for cotton. Okay, now when we are increase, suppose he is doing at saturated humidity condition for cotton, what will happen? This is the normal curve, stress strain, it's a normal curve for 65% relative humidity. For 100%, he will get little bit higher value. So same cotton yarn, so he is reporting this value. So S2 actually S1. So he is very happy, or the company is very happy, and I am producing higher fabric or yarn of higher strength. But finally, when it is tested in standard atmospheric condition, this is actually failed. Suppose your target is S2. So the mistake is being made is he is not following the standard procedure. Type of test equipment. So type of test equipment is very, very important. One common example I am giving, like, so type of test, suppose your weighing balance. When we go to any shop, the weighing balance we use, okay, the weighing balance is say we are for a shopkeeper where his actually maximum target is say 1 kg, 1 kg size. So you are giving say trying to test say get 500 gram. So that for that his maximum capacity is 5 kg. Maximum capacity is 5 kg. So if you are taking 1 kg material, it is giving correct value. Similarly, capacity of machine, suppose in weighing bridge, and where we use truck loading. So that in the roadside you will see that weigh bridge is there where we use truck or full truck load. Now, suppose in this 500 gram material you want to test in that weigh bridge. Do you think that it will give you the correct result? It's not giving the correct result because we have not selected proper test equipment. So proper, actually that the range of the material should be there. Like one UTM, universal testing machine, which is meant for testing fiber or testing say rope, thick rope of say 10 ton capacity. We cannot use that load cell to test the single fiber. So that will give you the wrong result. So type of equipment we have to see. Then test condition, speed, temperature, pressure, that we have to consider. If we increase the test speed, the data will get, the test result will change. Now, how to minimize the variation in standard test method? So to minimize all this variation, so standard test methods are there where all the details are given. Our actually function is just to follow step line by line. Then we will get the reproducible result. So the result has to be reproduced wherever you test. Whatever machine you have, but if you follow that particular method, you will get the reproducible result. These are the first is the ISO method, International Organization for Standardization. Then ASTM is the American Society for Testing and materials, okay, testing materials. BS standard, then DIN standard, which is Germany, they follow, and in India we follow BIS standard, okay. But all these standards, they are actually apart from few difference, but overall they are actually almost same result. And in this, all this standard, you will find different standard format. If you see a particular standard, there will be different format. And for a particular, it's like ASTM. In ASTM, if you go for fiber testing, there are different types of tests. So for each and every parameter, each and every property, there are different separate test methods are available. The general format and guidelines are, first it will be written a scope. Suppose for fiber length testing, so a particular standard like ASTM, ISO or something, anywhere, or BIS, so for fiber length testing, cotton fiber length testing, so that's given in the scope, okay, or strength of the fiber testing. So it's a given on the scope. First, scope of this is to test the strength of fiber. Second is the reference document. So for that you have to, you need different reference material from where this this standard was actually derived. Okay, so reference document will be there. Then terminology, like fiber length. If you take the, so what is the mean length, or maybe the span length, 2.5% span length or 50% span length, uniformity ratio. These are the terminologies will be discussed there. Then summary of the test method. So test method will not be discussed in detail. The test method will be given in different other documents, but here the summary, first summary will be there, then significance and use. What is the significance of this test? So this will be given. Then what are the apparatus? The test method, that standard will give us the apparatus. What type of apparatus? Like it's not that particular make, but it will be given a general construction of the apparatus that can be produced by different manufacturer, but the apparatus general construction parameters will be given. This will be the size, this will be the depth, or all everything will be there. Then sampling technique and conditioning, how to take the sample, what is the conditioning method, this will be given. And then detailed procedure, how to clamp, what will be the pressure required, everything, what will be the size, everything will be so what, how to condition, so everything will be given. Then how to take the result, how many result data test you have to do. After that you have to do calculation as per the specification, and then test report. So all this is the format of any standard, and that is common for all this. This all it is a general format for any standard. Okay. And then I told that the definition. So we must know, before we start testing, we must know certain, we should have certain idea. Like I told that the quality he is produced, it was I have given example, it's a 10 centinewton per tex was the target, I am giving 20 centinewton per tex. Is it the quality? It's not the definition of the quality. So first is the quality definition, which as per the ISO, the definition is that this is the definition of the quality. It's an ensemble of properties. So different properties are there. So for yarn, it's a standard strength, evenness, everything. This you take all these properties together or characteristics together of a product like yarn or a service. It may be a service, okay, service, which confer on the capacity to satisfy the expressed or implicit requirement. But this is actually, this yarn is for weaving. It has to withstand maximum 10 centimeter per text yarn. It has to have certain elongation. Okay, that is suitable for use, whether it's suitable for use or not, or fitness for use. That's quality. It doesn't talk about, it's a silent, or it doesn't actually talk about it has to exceed that. So whatever its requirement, you just give. Don't give more than that. That's not the quality. Okay. Next is the testing. Definition of testing is that a means of determining the quality of an item like yarn. I want to determine the quality, means here I am telling the strength of the yarn, characteristics of yarn, to meet the specified requirement by subjecting it to set of physical, maybe chemical, okay, or environmental or operating action or some conditions. So anything can be given. Like I want to test the blend percent of yarn, so I have to go for the chemical test. I want to test the elongation, mechanical. So all these things are called, taken together as testing, just to determine the capability of the item, okay, for specified requirement. Like this platform, its capability is to withstand this much load, maybe 10 kg, maximum 10 kg load, and for that this much thickness of the wood, or maybe half inch thickness of wood, or this much strength is enough. But if I try to give it a carbon fiber reinforced composite, high performance composite we are trying to, which is expensive, or maybe steel plate or stainless steel plate of certain thickness, which is very heavy and all this. Although it will perform, but it's not required at this stage. Okay. Inspection. We have testing. Testing means, testing requires some physical or chemical performance or activity, but inspection is actually overall you are trying to see. And testing means it is actually some specific parameter, like strength testing is one parameter, length testing is another parameter. For that you need different types of mechanical activity or physical activity or environmental activity. But inspection is little bit different from the testing. Is activity such as measuring, examining, testing one or more characteristics together. Okay, that's called actually a product or services. That is inspection. And comparing this with specified requirement to determine the comfortability. Like in a spinning shed ring frame, you are going there. You are entering, and you are suddenly you start breakage, loom breakage in ring frame or loom shed or fabric defect. You just take the fabric and just try to inspect whether there is any defect or not, or you just take the material and yarn and try to test. Okay, just you are not following certain standard method. You are just overall you are trying to see the not only the single characteristics, but you are trying to see the overall performance. Like I am taking this tuft of cotton, I am just overall seeing the, okay, this is some dark portion, some this leaf material methods are there. These are inspection, but for testing, as we have discussed, we need a certain instrument for that. And quality control, the quality control is the operation, it's operational technique and activities used to fulfill the requirement of quality. So our quality requirement is there. Quality requirement to achieve certain strength or certain uniformity. But for that, what we are doing, as I have discussed, we are testing the fiber, we are testing the this sliver, we are testing the machine setting, we are testing the speed, we are testing the gauge, everything we are testing, pressure we are testing. So all these things together, it's called quality control. Because all these activities are to achieve the certain required strength, required evenness, because that you are doing all this. That's why it's called quality. You are controlling the quality. Means if the quality is deteriorating, you will come to know at the back before you produce. You will come to. So you are trying to control. So this is not deviating from the standard requirement. And statistical quality control. Quality control is all these activities. Now statistical quality control is you are using statistics in it. Like you are making you are measuring this NEP. You are measuring the NEP count, but you are trying to measure the average NEP count, or what is the standard deviation of NEP count, or like your here it's a unevenness, like linear density you are measuring. What is the CB percent or variability in linear density? That we are testing here to achieve certain standard uniform quality. So using the statistics, you are trying to quality the application of statistical technique for quality control, like mean, median, mode, or maybe significance test. So that is actually statistical quality control. Quality assurance. Now quality control and quality assurance is there's entirely different actually concept. Quality control is actually you have the raw material, I have the raw material, and we are trying to control the quality. We are not allowing the quality to deviate from the target. That's the quality control. Okay, like I'll give you one example. Like you have got different vegetable at your home, and you are trying to cook a particular dish. So what you are doing, you are some frying or boiling something certain time. You are for certain time you are boiling. It should not be overcooked, or certain spice you are applying. Okay, and then you are getting certain quality. It's a quality control because your raw material is in your home. You are trying to control the quality out of this raw. Now, suppose the same quality, same test, or same here in the yarn, same strength and all this, we want to produce throughout the year. Throughout the year, the same test of material, one particular dish, same test I want to produce throughout the year. Like you just see the international food joint. Okay, certain just food joint, a particular dish you eat in Delhi or you eat in other city of the country, in Mumbai or Chennai, you eat the same, you will get the same taste. Same taste. How is it possible? And that is throughout the year. It's not the one day. Similarly, we are supplying one yarn to our supplier, and I am giving the exactly same material throughout the year. How is it possible? Only thing is that for what they are doing, they apply the quality assurance. Means the raw material which they are purchasing, they are actually totally controlling that raw material. Similar raw material has to be purchased. Like for yarn, fiber they are purchasing from a particular supplier, and that particular vendor, the vendor list is written. The vendor list is written based on the previous experience. If the vendor is actually, suppose certain vendor is not giving the proper quality, it is removed. So they know these are the vendors, they can supply proper raw material to me. For us, it's a cotton, suppose proper cotton, that's controlled. And that with beyond apart from this list, you are not going to purchase. Then come to the blue room. Blue room, you have written that you will, for this quality, we need, then after that you are getting that it is tested. For this variety you need this much strength, this much trash content, everything is written. It's a written. And if it actually this quality is within that range, then you are accepting for this quality. Then come to blue room. Blue room, it's written that this setting has to be there. This much speed has to be maintained. The maintenance should be this much frequency. Everything should be there. And it is written in the shop floor. It's written in the shop floor. Only the operator has to only follow. Blindly they will follow. This is for all the carding, draw frame, comber, everything, everywhere it's written. What will be the pressure, what will be the setting, everything will be. And if you simply follow these things, you will get the exactly same quality. And that's called quality assurance. You are assuring the quality. All those planned or systematic action which is necessary to provide the adequate confidence for a producer to produce a certain product. So you are getting this is actually quality assurance technique, where although it requires the testing, it requires quality control, everything is required, but quality assurance is little bit because where planned, you have actually total document is written. Like example, control of vendors for supply of raw material. You are controlling the vendor. These are the vendors suitable for this product. Chemicals, machine setting, environmental control, manpower training. Manpower training is another important for quality assurance. Without trained manpower, and trained means properly trained, then only you will get the proper quality. if you go to international multinational food giant, you will see these people those who are like frying of French fry or potato chips, frying. That they control the temperature, control everything is controlled. Okay, size is controlled, shape is controlled, everything is controlled. Quality of oil and spice, they are controlled, so that you are getting the same test. It's called quality assurance, and it's written in the document. And you suppose today one particular set of operators are there or staffs are there. Tomorrow they are changing, they are moving out. Now then what will happen? Again you have to train the person. It's not that. They are basically basic trained, but the document is written. He has to only simply follow the document. That's called quality. It's a quality manual is there. Okay, which is called quality management. So quality assurance there, then quality management, everything is taken together. Everything is starting from testing, inspection, it's very important. The quality management doesn't actually aim to assure the best quality. It's not the best quality. It's basically to ensure the consistency in quality. Consistency in quality. Like I am producing a C grade yarn. I am getting price for C grade yarn, not even B grade, C grade yarn. For that I am using waste raw material, waste like a poor quality. But throughout the year I am producing the same quality. So I am supposed to get the ISO certificate. ISO certificate for my C grade quality. ISO doesn't tell that you have to produce the best quality. It's not that. Quality management is not because I am getting the price for the C grade. If I tomorrow instead of C grade I am producing A grade, it's not, I am actually non-conformance will be there. I am not following the conformance. It will be failed. Buyer will be happy, but it is actually as per the standard you are failed, because you are not consistent in quality. Okay, so consistency is important. 4 main components are there, like quality planning. You plan the quality, how to quality control, quality assurance, and quality improvement. So you are today you are getting some standard quality, okay, continuous able. So with the same raw material, everything, can you improve this? Not by paying extra price, adding extra, but with this, can you improve this quality? So that's also consistent improvement has to be there. So for that, as we have discussed, standard atmosphere is there for textile testing of textile material. Standard atmosphere is 65 plus minus 2% relative humidity. Standard temperature is 20 plus minus 2 degrees Celsius. The problem here is that the tropical country like us, to maintain 20 plus minus 2 degrees Celsius, it's a little bit difficult, because the air conditioning load will be very high. So for that, the tropical and subtropical countries areas, the temperatures we are maintaining 27 plus minus 2 degrees Celsius. So I think we'll stop now. For now, and next class, next session, we'll discuss the overall course outline. Okay, what we are going to teach. This is all about the basic introduction, and this we will be using in subsequently. Okay, thank you.